In simplifying algebraic fractions, we occasionally need a process known as polynomial division. Before we do that, I want to take you back to something that you actually know very well indeed, and that's ordinary long division. You know how to do long division, but I want to go over it again because I want to point out certain things to you, because the things that are important about long division are also important in polynomial division. So let's have a look at a long division sum. Supposing I want to divide 25 into, let's say, 2,675. What I would have to do is look at 25 into 2, no way. 25 into 26, it goes once. And I'd write the 1 there. I'd multiply the 1 by the 25 and subtract and have 1 left. Hope you remember doing that. You were probably taught how to do that at primary school or the beginnings of secondary school. Next step is to bring down the next number. So we bring down 17. Well, we bring down 7 to make it 17. And now we say, how many times does 25 go into 17? Well, it doesn't go at all. It's not enough. So we have to record the fact that it doesn't go with a 0. Next we bring down the 5. So now we've got 175, and we say, how many times does 25 go into that? And it goes 7. And we can check that. 7 5s are 35, 5 down, 3 to carry. 7 2s are 14, and 3 is 17. Subtract, we get nothing left. So this is our answer. We've nothing left there, no remainder, nothing left over, and there's our answer. 2,675 divides by 25, and the answer is 107. Let's just look at what we did. We did 25 into 26 because that went. We then recorded that once that it went there, multiplied, wrote the answer, and subtracted. We brought down the next number. Asked how many times 25 went into it. It didn't go. We recorded that and brought down the next number. Then we said, how many times does 25 go into that? 7. We did the multiplication, wrote it down, subtracted, got nothing left, so it finished. Now what we're going to do now is take that self-same process and do it with algebra. So, let us take this. 27x cubed plus 9x squared minus 3x minus 10 all over 3x minus 2. We want to divide that into that. We want to know how many times that will fit into there. So we set it up exactly like a long division problem. We're dividing by this. This is what we're dividing into. 27x cubed plus 9x squared minus 3x minus 10. So we ask ourselves, how many times does that go into that? A bit difficult. What we ask ourselves is, how many times does the x bit go into this bit? Just like we asked ourselves how many times the 25 went into the 26. How many times does 3x go into 27x cubed? The answer must be 9x squared, because 9x squared times by 3x gives us 27x cubed. And we need to record that, but we need to record it in the right place. And because these are the x squareds, we record that above the x squareds. So now we do the multiplication. 9x squared times 3x is 27x cubed. 9x squared times minus 2 is minus 18x squared. And just like we did for long division, we now do the subtraction. 27x cubed take away 27x cubed, none of them, because we arranged for it to be so. 9x squared take away minus 18x squared gives us plus 27x squared. Now we do what we did before. We bring down the next one. So we bring down the minus 3x. How many times does 3x go into 27x squared? Answer, it goes 9x times. And we write that in the x column. So now we have 9x times 3x, 27x squared. 9x times by minus 2, minus 18x. And we subtract again. 27x squared take away 27x squared, no x squareds, but we arrange for it to be like that. Minus 3x minus minus 18x. Well, that's going to give us plus 15x altogether. And then we bring down the minus 10. 3x into 15x. This time it goes 5 times. So we can say plus 5 there. And again, it's in the numbers, the constants column at the end. 5 times by 15 times by 3x gives us 15x. Write it down there. 5 times by minus 2 gives us minus 10. And we can see that when we take these two away, got exactly the same expression. 15x minus 10, take away 15x minus 10, nothing left. And so there's our answer. Just as in the long division, the answer was there, it's there now. And so we can say that this expression is equal to 9x squared plus 9x plus 5. Let's take another one. So we'll take x to the 4th plus x cubed plus 7x squared minus 6x plus 8 divided by, or all over, x squared plus 2x plus 8. So this is what we're dividing by, and this is what we're dividing into. It's not immediately obvious what the answer is going to be. Let's have a look. X squared plus 2x plus 8 into all of this. Our first question is, how many times does x squared go into x to the 4th? We don't need to worry about the rest. We just do it on the first 2 bits in each one, just as the same as we did with the previous example. How many times does x squared go into x to the 4th? Well, it goes x squared times. So we write it there over the x squareds. And now we do the multiplication. X squared times by x squared is x to the 4th. X squared by 2x is plus 2x cubed. X squared by 8 is plus 8x squared. And now we do the subtraction. X to the 4th, take away x to the 4th, there are none, but we arranged it that way. X cubed, take away 2x cubed, minus x cubed. 7x squared, take away 8x squared, minus x squared. And bring down the next term. Now we say, how many times does x squared go into minus x cubed? And it must be minus x. And so we write it in the x column and above the line there. Next, the multiplication. Minus x times by x squared is minus x cubed. Minus x times 2x is minus 2x squared. And minus x times by 8 is minus 8x. do the subtraction. Minus x cubed, take away minus x cubed, no x cubes. Minus x squared minus minus 2x squared. Well, the minus minus is a plus, so that effectively that's minus x squared plus 2x squared just gives us x squared. Minus 6x minus minus 8x. Well, that's minus 6x plus 8x gives us plus 2x. And bring down the next one. X squared plus 2x plus 8. Well, x squared goes into x squared once. And so x squared plus 2x plus 8. And again, we can see these two are the same. When I take them away, I will have nothing left. And so this is my answer. The result of doing that division is that. Well, the one that started us off on doing this was, if you remember, x cubed minus 1 over x minus 1. And this looks a little bit different, doesn't it? Because whereas the space between the x cubed term and the constant term was filled with other terms, this one isn't. How do we cope with that? Let's have a look. Remember, we know what the answer to this one is already. So what we must do is write in x cubed and then leave space for the x squared term, the x term, and then the constant term. So what I ask myself is, how many times does x go into x cubed? And the answer is it goes in x squared. So I write the answer there, where the x squared term would be. X squared times by x is x cubed. X squared times by minus 1 is minus x squared. And subtract. X cubed, take away x cubed, no x cubes. 0 minus minus x squared is plus x squared. Bring down the next term. There is no next term to bring down. There's no x to bring down. So it's as though I got 0x there. Well, there's no point in writing it if it's not there. So let's carry on. X into x squared. Well, that goes x times. So record the x there above where the x's would be. Let's do the multiplication. X times by x is x squared. X times by minus 1 is minus x. Do the subtraction. X squared take away x squared is nothing. Nothing take away minus x. It's minus minus x. That gives us plus x. Bring down the next term. We have got a term here to bring down. It's minus 1. How many times does x go into x? It goes once. 1 times by x is x. 1 times by minus 1 is minus 1. Take them away and we've got nothing left there. And so this is my answer, x squared plus x plus 1. And that's exactly the answer that we had before. So where you've got terms missing, you can still do the same division, you can still do the same process, but you just leave the gaps where the terms would be. And you'll need the gaps because you're going to have to write something up here in what's going to be the answer.